All right. Welcome to day 7 of the Advent of Cyber 2022. Today's task is called Day 7 CyberChef Maldocs Roasting on an Open Fire. So let's go ahead and get to it. All right. In this story, we've already got the attack box open, or the machine open. So we're gonna go through the story real quick. In the previous task, we learned that McSkidy was indeed the victim of a spearphishing campaign that also contained a suspicious file or a suspicious document, division of labor load share plan. McSkidy accidentally opened that document, and it's still unknown if that document and what that document did in the background. McSkidy has called in the in-house experts, which are you and me, and we're here to explain what that malicious document may have done and see if we can't find the domains it redirects to. Malicious documents may contain suspicious commands to get executed when they open an embed malware as a dropper, like malware installer components, and may have some C2 domains to connect to, or command and control. Our objectives today are to learn what CyberChef is. We're going to look at the capabilities of what CyberChef can do. We're going to leverage CyberChef to analyze this document that we found yesterday. And then we're going to look at it and see if we can't use it to deobfuscate, filter, and parse all the data within that attached document. So we've already gone ahead and deployed the lab. So let's go through and look at a quick overview of what CyberChef is. So CyberChef, it's a web-based application used to slice, dice, encode, decode, parse, and analyze data or files. CyberChef layout is explained below. In an offline version of CyberChef is in the bookmark on our machine. So let's go ahead and open up Firefox over here, see if we can't load CyberChef, and we can walk through it. Oh, it looks like I might be in the way down here. Maybe I should make myself a little bit smaller. What do y'all think? Let's see. Can I make myself smaller? There, now I'm not so big. Maybe I'm not in the way. I don't want to be in the way from things that are going to be shown. Okay, now here up at the top we have CyberChef. Let's go ahead and open that up. And we will see that this looks just like what we've got over here on the left-hand side. I'm going to go ahead and blow this all the way out so we see. I am kind of in the way, but that should be okay for the stream. All right, so CyberChef, we've already talked about what it is. Let's go ahead and look at the panels. Panel 1, we add our text to, that's our input. Panel 2 contains the various functions, so our operations and functions are over here on the left-hand side. And we can drag and drop these functions into here. Let's see, what do those functions do? They can encode, decode, parse, search, we can filter everything within that attachment. So drag and drop functions or recipes from panel 2 into panel 3, and we've already discussed that. For the output from the recipes are shown in panel 4. So where's 4? 4 is down here where the output is. And at the bottom we've got this bake, the click to bake, or we can run auto bake, and we're going to go ahead and have auto bake turned on. That way we see it instantly. All right. What do we want to do? Let's start looking at this. Using CyberChef for malware doc analysis. Let's utilize these functions. So we've already gone ahead and opened up CyberChef. So let's go ahead and open up the file. So we'll click on here, open the file, and open up the division of labor load share plan doc. Go ahead and hit open. And look at this. Let's go ahead and see if we can increase this so it'll kind of go up, because we don't really need the input window. That's good. That way I'm kind of out of the way over there. All right, so we've opened up our document into here. Now what do we want to do? The second Our second part here is we want to extract the strings. So we'll go over to the left-hand side and we'll type in strings because that's our operation. And we'll drag that over here. And now, look, we've gone ahead and cleared out everything that's not a string. But the issue here is that we don't have enough characters because a lot of stuff is missing. We had a whole bunch of stuff in this file. So what we need to do is we need to make sure that we click up here to match all printable characters. And as it says here, use the strings function from the left panel to extract all the strings by dragging panel 3, or dragging to panel 3 and selecting all printable characters as shown. So we've done that. And we'll move on down to the next one. If we examine the result, we can see some random strings of different lengths and some obfuscated strings. Let's narrow down the search to show the strings with a larger length. Keep increasing the maximum length until you remove all the noise and are only left with character with a meaning string. So as we see in here, what it's talking about is BJB is a string. All of this is a string. These are strings. But if we scroll down, you see this is a long string, right? We still have all of these on here, and we want to clear out all of this. So we want to clear out new macros. So if a minimum strength of 4, so if I go to 5, now word is gone, right? So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I go to 9, then we're going to clear some more out. So what we want to do is we want to get to the point to where we clear out enough to where we're only left with this junk right here. Because this is what we're going to be working with. So if we put in about, what, 100? Like, we're still stuck with this string here. So we put about, what, 150? We still have stuff. Let's go to, like, 250. No, we still have... Can we go up some more? 51, 52, 53. All right, that cleared out our top line. Do we have anything else down at the bottom? No. Okay, so we just have the output that we want to look at. Perfect. So now, what's our next move? We've got all printable characters. We've got a minimum of 258 because now we're seeing the junk that we wanted to look at. So now we move on. And what's one thing we see right away in this? We see that there's patterns, right? We see patterns in here of square brackets and underscores. So what we want to do is we want to figure out a way to remove all of that. Let's see if we can't clean this up some. So how can we do that? Let's remove a pattern. Attackers often add random characters to obfuscate the actual value. If we examine, we can find some repeated characters like the open and close square bracket and the underscore. As these characters are common in different places, we can use regular expressions or regex within the find and replace function to find and remove these repeated characters. So let's go ahead and go into here and type in find and replace. We'll do find and replace. There we go. And now we're going to use regex or regular expressions. So we're going to go ahead and put in our brackets. Whoop. So now we've got our brackets. Now inside these brackets is what we're going to work with. Once we've got these brackets in here, if we go ahead and put a backslash into these brackets, you'll see what happens. Boom, it clears out a whole bunch of stuff, says that the find and replace syntax isn't there. So what we want to do is we want to use that backslash to actually clear out these three. So we know what they are. So let's go ahead and do backslash bracket. Let's do backslash closed bracket. And let's do backslash and underscore. And look at that. Now we've cleared out those specific ones, and it's a little bit cleaner now. Now we can actually see CMD. We've got a space in here. We've also got, let's see. We've got Word. It's a little bit cleaner. We can see what's going on. So let's go ahead and move on to our next. So we can see that it is evident from the result that we're dealing with a PowerShell script. And why is that evident? Well, let's go over here and look. It's a little bit better human readable. We can actually see PowerShell in here. We still have some characters. And you know what? We can actually go ahead and, if we want to, we'll make it even cleaner. We can go ahead and, let's go ahead and add the that caret in there. Oh, look at that. Now it's a little bit cleaner. Now we're looking pretty. Didn't tell us to do that, but we're gonna go ahead and do that. Okay, so now what's our next thing? We got stuff in here. Now what do we want to do? We want to drop bytes. So to get access to the base 64, we need to remove the extra bytes from the top. Let's use the drop bytes command. So when they're talking about the extra bytes from the top, we're talking about what's going on up here. So let's go ahead and do the drop bytes. Drop. If we can type it, drop. Sounds like Beastie Boys. Drop. Drop byte. There we go, drop bytes. And in here, we're going to drop the bytes. Function to keep increasing the number until the top is removed. So just like we did up here in the strings to remove stuff, we're going to do the same thing down here. So we have the length, and you see bytes are, we're actually talking about bytes of data. So if we back this down all the way to 0, right now we haven't removed any bytes. So if I remove 1, now we remove a C. If I remove 2, we remove an M. And we remove a D. And you can see how it's doing that all the way through. So what we want to do is we want to clear all of that out until we get what's left in here. So by looking over here, it looks like they've gone ahead and cleared out 124. This looks like our perfect number. So we'll go ahead and put 124, kind of help us go through there. Which that, to me, looks like it cleared out more than what we want. So we've got BAAF. So although they have 124 on here, I think, you know what I'm going to do? I'm only going to clear out 1, 2. There we go. We're going to clear out 122. Because as you can see, when we clear out 121, we're still left with that top. So we'll go ahead and clear the next line. And now we've got all this left. So we're going to clear 122 out on ours. All right, base 64. Now we are left with base 64 text. We'll use from base 64 to decode. So this is, if you scroll down at the bottom, you can see the equals equals, which is a sign that is base 64. There are a whole bunch of base 64 decoders out there on the internet, but lucky for us, CyberChef has one module in it already that we can do. So let's go ahead and do from base 64. We've got all these different bases. We got base 64 here, so let's go ahead and grab that one. And now look what we got. Now we got some more garbly-gook and junk. All right, what up, Fraser? So now we got more in here. Let's go ahead and figure out what we got to do. So now we've gone base 64. Now we need to decode this. The base 64 decoder result is clearly indicating that's a PowerShell script, which seems like an interesting find. In general, the PowerShell scripts are usually done in Unicode UTF-16LE, so we want to decode that text. So let's go ahead and decode text. Let's drop that in. And it automatically puts in UTF-8, which we don't want to decode that. We want to decode 16LE. Well, that doesn't look right. We've missed something here. Now we got Chinese characters. What do we got going on? Oh, there we go. Look. See, I removed that. All right. We were trying to do it and look pretty, and we removed the carets, and that kind of messed up our evaluation here. So by putting in the character, we actually messed up what the output was, or the character. By putting in the caret, we actually messed up what the output was over here, and in doing that, would have just shown Chinese characters, which that's not what we're looking for. So now we've got that fixed. Now we see base 64, and this is what we're looking for. All right. So now looks like we probably need to kind of clear out some more characters in this. So we once again have common patterns. So on 7 it says, Forensic McBlue observes various repeated characters such as these within the output, which makes the result a bit messy. So let's go ahead and use our regex find and replace and clean this bad boy up. Find and replace. And you know what I'm going to do? Instead of typing all these in, we're going to put it over here. Ooh. Here we go. We got to copy and paste, and we're going to do our registry. Let's remove all these spaces in here. Okay. Good deal. All right, so now we see we've removed the repetitives, and it's nice and clean. Looks a little bit cleaner. We can, now with the human eye, we can actually start looking at some of this stuff. We can see that it looks like they're setting a variable. Looks like that variable is going to be 8IH567 is what they're going to use as a variable. It looks like on here we've got some arrays, and by looking at this, in here in computer language we always start with 0. So here this would be the 4th part of the array. This would be the 1st part. This would be the 5th. That would be the 3rd, and so forth. So if we actually look at the array in here, we can see that this is going to be the first YST. Directory is going to be 2. MIO is going to be all the way to here. Going to be 3 or 2. That's going to be 4 or 3. So you can see, so we have S, and then we got YST. So it looks like we're going to spell system, and then directory, or system.io.directory is probably what we could break all that down, but you know what? We don't need to. We're going to keep on moving through, but you can see how human, you can go in and read this. You don't necessarily need the computer to break it all down. You can go in and read if you know what you're looking for. All right, so now that we've got this, let's move to our next task. Task 8, let's find and replace. If we examine the output, which we just did, we'll find various domains and some weird lettering, like closed square bracket BH2 underscore before each domain reference. Let's do a replace function so we can, okay. Also, let's do a replace function of closed bracket B2H underscore with HTTP. So let's, before we do that, let's kind of look and see what they're talking about. So in here, we kind of scroll through here, we'll see closed bracket BHT underscore S, and then it kind of looks like we've got, right? Looks like a web page, kind of same here. And it looks like they probably got to replace within this code. So what we're going to do is let's go ahead and replace it for them. Let's find out what this stuff says. So if we go into here and let's replace this. It's not registry, or it's not a registry. It's not a regular expression. It is a simple string. So we're going to put that in as a simple string, and then we're going to change this to HTTP and already bake it out. And there we go. So now we actually look like an actual web page. Look at that. That's called obfuscation. They're trying to make it look like it's not something that it actually is. All right, so we've gone and replaced. Now we can use another module, another operation on CyberChef that extracts those URLs. So it's going to yank everything that we've got over here and leave just the URLs. So let's go ahead and do that. Let's extract those URLs. Ooh, now we're looking a lot prettier. So we've got https bettyyandit.thm /file/mysterygift.exe with a ampersand sign. Looks like we got a whole bunch of them. What we probably want to do is we probably want to remove these and put in a break, a line break in there. So what we can do, oh, that's what it is, split URLs. So let's go ahead and split these URLs. Split. Whoop. What split? I was about to type split URLs. All right, and let's split not on that delimiter, but let's split on the ampersand. And now, look at that. Now we're looking real pretty. So now we've got 4 websites. But right now, as a incident response person, you don't want to copy and paste this because these could be malicious, or these are the malicious. These are malicious URLs that we've just found. So what we want to do before we shoot those off to our SOC analyst is what we want to call. We want to do what's called defanging them, right? So if we go over to here, let me scroll down. I think they're going to have us defang this. Yep. So let's go over and use defang URL. Defang. Let's defang the URL. And what defanging the URL does is it's going to clear out some of the stuff. So now we've got XX for the T's. We've got brackets around here. So now we can copy and paste this stuff and send these URLs directly to someone, the SOC analyst, anybody else, and they are not live. They are not links. So if somebody were to click on them, you can't click on them, right? They're not live links. So just like it says here, before passing these domains over to our SOC team for deep malware analysis, it's recommended that we do defang to avoid accidental clicks. How did this actually happen to begin with? It happened with an accidental click in an email. We've already discovered that. And the last thing we want to do is find these malicious URLs, shoot those over to our team, and have another accident. I have gone ahead and already filled in everything on here. So we can go through these answers real quick. So what version of CyberChef are we using? That's up here in the top left-hand corner, 9.49.0. How many recipes did we use? We used 10 recipes when it all breaks down to it. We found a URL that was downloading a suspicious... Man, I cannot speak. We found a URL that was downloading a suspicious file. What was the name of that file? So that URL is right here, and that's the name of that file. So mysterygift.exe. We'll remove the brackets and put that over here. And then it says, what is the last defang URL of the Bandy Yeti domain found in the last step? So that would be this last one here. Copy and paste and put that one over here. It'll be good. And then we're looking for our mystery flag with the golden link, and that is secretsanta.thm, and our golden ticket is THM mystery flag. And to round it all out, if you want to get more practice using security information and in event management, you can go into the security information and event management module and dive in a little bit deeper. But for now, I am going to close this one out, and I will see you tomorrow. I will see you tomorrow on day 8 of the Advent of Cyber 2022. Until then, see you guys.